Welcome. My name is Jonathan Bruce. I'm here with
Pat Patterson.
Today we're going to talk about unleashing the potential of big data on the Salesforce.com platform. So it's great to be here. Let's dig in. All right, first we got the forward-looking statement. Now once we had the a different-looking statement, no longer which you can use, but what the forward-looking statement really means is that everything you're going to hear today is all very forward-looking. So keep in mind as we walk through all the different kind of product features that we talk about, if you're making any purchase decisions, you should make those only on our currently available product line. So Pat, let's dig in. Any thoughts before we get going?
Why don't you introduce yourself to the listeners?
Yeah, let's do that. So I'm Jonathan Bruce, product manager for Big Data on App Cloud. So my job is all about thinking about how we bring big data technologies and the way of thinking about data at large scale directly into our customers' hands.
And you've been at Salesforce for?
Just over 3 years.
Wow.
Prior to that, Progress Software, and then prior to that, I was at Sun Microsystems when I worked on a little technology we used to call Java. We still call it Java.
Oh yeah, I remember Java.
Yeah, whereas the JDBC spec lead and architect.
So you've got a long history on the data side.
Yeah, definitely. Kind of data is something I've lived and breathed. Right, really, when I think back to my college careers, I spent a lot of time on databases there. So for me, one of the really attractive things of coming to work at Salesforce was what I really got to know from attending a few Dreamforces before I joined Salesforce, to see what people were doing on the platform, and enabling and empowering our user bases to work with big data directly on our platform. I think it's still really exciting.
Awesome. And I'm Pat Patterson. I'm a member of the developer evangelism team here at Salesforce, and so let's get started. Give us the big picture, Jonathan. What are we talking about big data? Why is it important?
So I thought it's useful to start with a kind of nice quote from some of the analysts, and we've heard an awful lot about big data over the past few years. It's been written about an awful lot. Really, what I really want to kind of get into today is talk about how can we start executing on the promise of big data. And in the Salesforce context, it's really about knowing a ton more about your customer right across the lifecycle of your customer, such that you can build new and interesting services around it. And also going to get to a point where you can iterate towards more of a data-driven future. And that all takes data. You need to have the full breadth of your to actually do interesting things. So we're going to really get into some of the details of how far we've gotten on that today.
Cool.
So let's move forward here. So I think you think about how much data has been generated. A quick look around any large public place, you see everyone playing with their smartphones or whatever else. And I think we can very quickly come up with this figure. It's saying that really 90% of data has been generated in the past 12 months. And I think it's very interesting the fact that this is commonly assumed to be the case. However, I think it's almost at the point whereby I think that's almost potentially a low figure. I think that we don't quite have a handle on how much data is being generated.
Certainly exponential growth.
Absolutely, no question about it. And the kind of events we see, all this data that our customers are generating is hugely actionable. What we really want to get into today is how can you start chipping away at that data to start doing something interesting with it. But I also want to make a couple of other points that a lot of the customers I tend to talk to are coming to our platform because they're operating in a highly regulated environment. They may be biotech or pharmaceutical or banking or financial firms. And a lot of these firms are thinking about data archival or data management such that they can retain their data because they have to for a statutory amount of times, for 7, 15, 30 years, things like that. And not only do they want to keep the data that they have, manage it within our platform for longer periods of times, there's also an inherent anticipation that they want to keep that, such that they want to do some really interesting analytics across this data. They want to be able to look back upon this to understand what's going on.
So we're actually moving away from the situation of this archive data being write-only data. We're going to want to read it back and analyze it.
Oh, completely. And I think that's very much a philosophy we're kind of sticking to. That it may be in an archival form, but it's really about nearline storage. We want to keep it such that it's still accessible to you day to day because it's hugely actionable, and we want to eliminate any gates that are there to prevent that action. All right. So let's talk about, Pat, where we are today. So if you want to understand your customer, in the Salesforce platform that we understand today, there's a ton of data acquisition, there's a ton of data management and machining that occurs before you actually can do something interesting with it. And you can analyze or take action with your data via either the context within our platform using the Wave Analytics application, or via our kind of classic top-tier clients, via sales or service or marketing. So that, what's interesting here is that the firewall to actually interacting and actually understanding your customer is actually quite high. So let's imagine where we want to go in the future. Is we really want to push that firewall down much further, so we can be that much closer to our customer data, so we can acquire and store and think about our customer data in terms of billions of records. We talked about this earlier on. What's going to be cool here?
Yeah. Was it 1 million records? That's not cool.
But billion records is way cooler.
Yeah.
Absolutely. So it's about, a big object is our new way of thinking about billions of records in the force-down perspective. It's not billion, tens of billions. It's also the ability to be able to wrangle, to machine, to actually work with that data at scale. Because you cannot assume the same kind of contracts that you had there before are going to work at this scale.
Right. You're not going to run a report on 10 billion records.
No. Reports and dashboards will not work at that kind of scale. They're not built for it.
Right.
But you see, if you are able to kind of plug in these two kind of supporting components, the ability to have human-driven analysis, or indeed to make more data-driven applications, is that much easier on the platform. So let's look at some of the detail that we might find here. So let's look at the kind of key use cases that we might see. So the top use cases that we hear about all the time is Customer 360. And what Customer 360 is that I want to know more about my customer. I may have data that is potentially, say, loyalty data, or log file data, or usage data, or all this kind of historical customer information. That if I were able to, work with that in, partnership right next to my highly transactional CRM data, there's no end of amazing things I could do.
Right. You're extracting additional insights.
Precisely.
And so the potential here is you're adding to the top line, by being able to better service, better market to your customers.
Yeah, because you already know something about your customer in your CRM, but you can enrich it that much more with data that you bring in. We'll look at through a couple of kind of key demos as to how might one build a new service when you marry that kind of data together. So it's also about data retention. You made the great point earlier on, being able to retain your data natively on platform for a specified amount of time, and that really helps so many of our customers who are coming to our platform. They maybe have been with us for some time or are now considering us, given our trust value. And this comes under the auspices of something we've called Salesforce Shield, whereby you want to be able to maintain your data across its life cycle, for a specified amount of time. We already do that with something called Field Audit Trail. The data archive is our kind of future perspective on this. And then lastly, it's about event capture. We've had a very successful product that I'm sure you know called Platform Monitoring. Adam Torman runs this.
Mm-hmm.
And that's all about being able to monitor what people are doing on platform, who's clicking on what, who's running what report, such that we can understand usage metrics and really derive a deep understanding of what users are doing on platform. The degree of events that people are generating, you need to go somewhere. So BigObjects is a new retention medium for things like Apex events and login forensics as well.
So all of a sudden you'll be able to capture much finer granularity of events.
That's right. So that's a great, very, very real kind of visceral example of the kind of capabilities that we have here. So let's dig deeper here, Pat, and let's look at some of the technologies that we have to play here. I think from this point forward, for everyone on the webinar, this is a great time to start sending our questions in here. We're going to get to these towards the end of the webinar. We're going to get to pretty technical here pretty quickly. So what are our key storage services? So BigObjects are the new fundamental paradigm that allow you to imagine and to think in terms of billions of records natively on Force.com. And then on top of that, we're dreaming and thinking of new services where data archive will sit on top of the ability to use this new retention medium such that you can have what I call policy-driven data retention. So
So if a case is has been closed for 3 months, it might go automatically into the archive.
Exactly, yeah. So you can set a policy to you kind of move these across. And that does two things. Number one, it kind of gets these cases out of scope because you don't want them being played with anymore, but also it's a great strategy to manage your storage so that you can offset some of that storage as well. And that ultimately is really, really contributory to some of our very large customers who've got very highly scaled orgs that may be seeing some operational kind of hot points. It's a great way of managing that too. So for kind of classic and well-known services like Sokol, our well-known and highly used object query language, we have a whole new sort of set of ways of thinking about how you run Sokol on top of BigObjects that I'll talk about in a few minutes. And then I'm going to introduce something super exciting that we launched just past Dreamforce called Asynchronous Sokol. So this is a new ability to write Sokol across any object in a federated form.
So not just BigObjects, we get to run long-running asynchronous query on standard objects and custom objects.
Yeah, and external objects too. In fact, everything works. Yeah. So you can they run resiliently, and they're in that sense they have very, very high guarantees that they're going to complete. But what's really, really cool about Async Sokol, as we'll see, is that you direct where the result can be. So it gives you a kind of a pipelining mechanism that ultimately you can chain together. So really, really exciting here. Now I call out API as well. We'll look at what that means in a second. But bulk API is the kind of key thing that we've been working on as well to basically open up this well-used, highly deployed API such that we can have the kind of ingest capabilities we need for the big object world. So let's look at some details here. BigObject, as I said, means hundreds of billions of records on the App Cloud.
And that's hundreds of billions of records per org.
Absolutely.
Not just hundreds of billions of records in aggregate.
I'll go further. You could have one object with hundreds of billions of records. That's totally possible. But it's built. How have we done this? Well, it's built on Apache HBase, and it's powered by Apache Phoenix. And in effect, BigObject is our abstraction of our trusted linear storage NoSQL solution. So it's deployed right across our service. And think of Salesforce today. Salesforce today, in its current form, is an abstraction of a well-known database. And this is effectively the same thing, but we're abstracting a different kind of database so that we can go after some very different use cases. And it's fully available across all production sandbox instances, and as you asked me earlier on, developer too. So everyone gets to use this if they want to be part of our pilots.
And in fact, aren't we already using this in field history?
Yes, we're already using BigObject in a commercially available product called Field Audit Trail, where we're taking our field history and we're moving all these field history records into a new kind of BigObject called Field History Archive, and we're doing that based on policy. So that's could be the basis for data archive down the road.
So I'm seeing a number of trade-offs here between the custom/standard objects and big objects. Developers are going to have to think carefully about where they want this data to go, because you've got, on the one hand, you've got this huge volume, but on the other hand, I'm seeing here it's immutable, there's no transaction, so we're going to have to, developers are going to have to get to grips with this, carefully understanding this trade-off. Right?
That's a great point. I mean, I think the way we have packaged these objects look and feel much like any other SObjects. You're absolutely correct. They have very different characteristics. There's no transaction with these for very good reasons, that we already have a great transaction engine. We don't need two. But by not having transactions on this particular store, we get massive storage capability, we get super fast ingest capabilities, and it makes it much, much more suitable for doing the kind of machine, batch type analytics we want to offer on top of this. But the key for this is that it has the same level of trusted storage capability that we have in our current infrastructure. So any records that go into a BigObject, any records that go into an SObject are all backed up, replicated, so they have the whole same kind of value that you would expect. But it's targeted at immutable or data that does not change. So that's why I've mentioned archive data. That's why I talk about event data, external historical loyalty data. That's what this is really geared for, of which there is a tremendous amount of data out there.
Right.
And one could almost say today in some of our very large orgs, a lot of the data in there hasn't changed in years. It shouldn't actually be in our current storage mechanism right now. we could potentially move things around and offer a much kind of more optimal runtime scenario.
So the prospect here is that a customer could move a large amount of this pretty much static data into BigObjects and have a much lower, free up the data storage on the classic
that is
side.
Very much the case, and there's a ton of advantages that come with it because, in effect, that's really kind of database management. You're making your indexes smaller. Things are leaner. Things will run in a more optimal fashion. Okay. So what is the kind of look and feel that you get? So BigObjects, as we'll see in our demos in a few minutes, give you the familiar look and feel. We have the typical data types that you expect today, and this is I'm very much speaking about our current pilot that we have in place. We've got support for string, number, date, and in the future we'll have support for a native JSON type. That's really exciting for a bunch of different use cases. We also have the ability to do lookups, so you can build a lookup between a BigObject pointing to an SObject. We'll look at that in a sec, and then we're working on master detail down the road. But it's exposed by all the APIs that you would typically expect to see, just as we talked before.
So this is a bit like external objects. From the developer eye view, it looks, once you've set it up, it looks pretty much like what we're used to dealing with. The metadata API is there. I can go get the list of fields.
Yep.
I can make SOAP and REST calls, but I get this kind of fancy new feature of being able to run these long-running queries.
So just like external objects that have the API suffix __x, we have __b for BigObjects. So they're distinct, and by that, we're very careful to ensure that you can understand exactly the right characteristics, both from a metadata and from a doc perspective.
So a uniform interface, but quite a different implementation.
Very much so. Very much so. So, we touched upon this, a couple of this already. We have new services for synchronous and asynchronous Sokol. Let's look at the details on that in a second. The reports, dashboards, and search are not supported, not really in part of our initial scope that we're going after here. Search may come, but reports and dashboards definitely will not work natively. But I'll show you a little trick to get those to work in a kind of roundabout way later on. Okay. So let's look at the BigObject and Sokol perspective. So why do we have constrained Sokol in the first place? So if you think about the underlying data store that we have, it's built such that ad hoc queries are not how this thing is built for. It's built very much for queries that you have thought through, and you shape your data such that you know the kind of queries that you're going to see all the time. So that's why Field Audit Trail has what we call a custom a key prefix that's being thought through such that when you query, you have to filter in this order by field history type, parent ID, and by created date, and you must do so in that order. So we've already thought through the kind of typical patterns that you would see. And in our current iteration of custom BigObject, you can filter on ID only.
And that's the record ID,
yes,
and not the parent ID or a lookup or anything.
No, that's specific to record ID today. Now that's just our constraints today. Now we realize that could be very constraining for
just
a lot
a little bit.
Yeah, of course. But you'll see from Asynchronous Query, we also give you a lot of flexibility that was not there. But we're very conscious of that, so we're looking at introducing a couple of key.
So here we're talking specifically about synchronous.
Yeah, synchronous
traditional
query.
Sokol.
So Sokol that you want to run and have a response to in 120 seconds or less. So with custom key prefixes and secondary indexes, we're basically going to bring in the classic big data pattern, whereby you shape the data to match the queries that you're going to run against it at all times. So you'll have the ability to basically define your custom key prefixes, and we'll also introduce the notion of secondary indexes as well. But you yourself, our developers will be able to define this for themselves, which is in direct contrast to what's capable right now. If you want an index today, you got to call support and get your skinny tables, and it's a little more involved than I would like. So we really want to put this into our developers' hands.
So this is just basically part of this trade-off that to get queries on this huge amount of data, you kind of have to give us a little bit of help.
Yeah, that's right. That's right. So I think the custom prefix, that's a part of the future perspective. So I think we're going to see that happen over the course of this year. So let's think a little further and then go, okay, right, if Sokol is very constrained, our traditional Sokol, what does asynchronous Sokol give me? So number one, what this is, this brings us our Hadoop capability directly into our customers' hands, whereby you can do aggregation and filtering across all records. But we've done it such that we keep the look and feel of Sokol in your hands. So you can write a Sokol script that would query just BigObjects, could join with an SObject, could join with an external object, and you could direct the query the query response to a specific object which is representative of your result set. And I think the key here is that these things run resiliently, and you can run them in parallel because we're using our underlying Hadoop infrastructure to actually execute this for you.
So you could have a query that takes an hour to complete.
Yeah, you could have a query that runs for 12 hours and would be guaranteed to complete. Okay, wow. That's very empowering for a bunch of data preparation, data ranking scenarios. So if you're going to strip down the anatomy of asynchronous Sokol, it kind of really breaks down at this. If we wanted to run a query across a big object called writer record 1, we are going to query a set of fields, end time, start time, and this is an example I'll use later on, and I want to say filter on this particular star rating. I actually target the answer of that to another big object here, and then I map each of the fields I'm querying to the target fields of that object. And what this does is it allows me, in this instance, I'm taking a record here, writer record 1, which has got 1.6 billion records, and I'm going to reduce it down to something more manageable, to about 12 million records that I can ingest into another kind of capability.
So you always have to have a place for it to go. It doesn't just kind of materialize. I mean, it doesn't make sense with this volume of data for it to materialize into a list or something. It goes into another big object or an SObject, or I guess even an external object.
Yes, assuming you've got external object writable capabilities on. But yes, I mean, you could, obviously there's some, we'll get into this in right here. I think there are some considerations that you have to have in place as to, if you're going to write into an SObject, you don't want to blow away how much data you have here. So there's some care you have to take care. But you're right, the kind of flexibility you have is like, I could make a chatter post if I wanted by just doing an output to a feed item, and we've done that. So it's very, very flexible because I'm just thinking in terms of the API.
So you can create 1 billion chatter posts.
No, I don't think we're going to do that, but that's a shout out to anybody in the audience. If there's anybody out there who wants to write 1 billion chatter posts, I'd love to hear from them. Anyway, so what is the kind of Sokol coverage we have to date? We have the support for key aggregate functions, so you can do counts and averages and some, key Sokol syntax, so we can do group bys. Having is going to come in Spring 16. Key where clauses we have as well. And the key for here, more than anything else, the key here is that with relationship queries, you can join together with your core CRM data. That's a key thing that we did, so you can look up and actually kind of enrich the perspective that you have.
And just to make clear, when you say Spring 16, you mean the pilot that will be along in the Spring 16 timeframe.
That's right. So we're going to have a pilot refresh, think of it that way. Now, we touched on this a few minutes ago. There are new limits at play here. The query and result set models are as yet undefined, but I think you need to take care. That throwing 50 billion records as an SObject is not a prudent thing to do. But you more flexibility with the big object frame, and we do limit how many parallel queries you can run today, up to 3. But that's just our current pilot limitation right now. Now, it's very API centric right now. Just to call out 2 enhancements I hear about all the time is that Apex will have an async query verb capability in Apex natively. We're going to look at that in the next release or 2. And additional grouping and aggregates. One of the reasons I wanted to do this webinar is to get feedback, to see what other aggregates people would like us to think about. But in terms of the data reduction, the data processing capability here, in terms of data sinks and the data sources and the data sinks, we now have this really kind of flexible means whereby you can process data natively on platform, move data from SObjects to BigObjects, or in reverse, all using the asynchronous Sokol as your means to kind of do the filtering and grouping and aggregates that you would want. Hugely powerful. Now, we always think about, how would you have done this before? Typically, our developers would have taken the data out, done some of the machination off-platform using whatever tool that they had, and then they put the data back in.
Right.
So the key advantage here is that none of that has to happen anymore.
So it's going to be faster, I would guess, because you're not having to pipe all of this stuff over the bulk API.
And more reliable. You're not going to eat up your limits. You're not going to put data in a certain scope whereby you may be moving protected data out. No longer part of the
there's regulatory issues of moving data around for sure.
Yeah, absolutely.
And what's coming very clear out of this slide for me is that this dovetails very neatly into Wave Analytics and IoT Cloud.
Very much so.
we have the prospect of creating huge amounts of data coming from sensor readings.
Yeah.
Okay, demo time.
I think so. Yes, I think we've heard lots of slideware. Keep those questions coming in. Let's hope this has not timed out on me. It has not. So let's talk about a demo I have in mind here. So here we have a Winter 16 org with both BigObject and Async Sokol turned on. Now, by the way, we should mention everything I'm showing here is in pilot today. I'm definitely in the customer recruitment mode. If you would like to be involved in the pilot, if you're a developer and only have a DE org, you can contact me directly. Or if you are a formal customer, you contact your AE and they'll wire you into these pilots.
So you're John Bruce on
at John Bruce Twitter. On Twitter is probably the best way to catch me. Okay, so here we have a typical org. So let's set up the scenario here. So what we're going to do here is we're going to help a car writing service, and there's a number of car writing services that I'm sure we all know. So I have one example of a car writing service here where they are looking to potentially do some new things with the data that they generate with their app. Okay, and one of the services that they thought they'd like to introduce is a new, shall we say, commute service. And what they want to do is they want to look at the patterns of all the commutes that take place, such that they can understand where they start and where they end, and at what times, and what kind of class of service that they get. So what we want to look at is take a perspective as to how can we take that data that's being generated from each of these apps. And if we were to marry that to data with the contact details they have on Salesforce, could they do something interesting to understand whether they could offer a new service?
Right. So basically, effectively doing a join.
Yeah, exactly. So we're going to define a couple of big objects here, and I have defined these already just so everybody can see here. And so you can get an idea of what this writer record here is. You can see it's a big object, because it's defined with that specific API name, and we've got some key components within that definition here. So we know how much they paid, when the write took place, its start and end location, who the writer name was. Oh, that's an interesting one because look, we got a lookup here. So we're actually looking up to that contact, which is actually our person object we're having right now. So here's the join. This is where the relationship is really kind of taking place here. And then so this is a pretty flat profile. Now, in this big object, what we have to date, and I'll just run this query again. Hopefully this timed out, of course. So let's just bring this back up again. There we go. So let's run that query again so I can show you that this data is actually real. Yeah, we'll run this query here, and we're just going to pull out an ID.
So this is just regular Sokol.
Regular Sokol that we have here. We're just going to do a quick query here, and then you can see that Sokol is produced right here. Okay, and you can actually look at this record here. If I were to, do this, I can actually show you that record is actually, all wired into the platform here. We can take a quick look at it here. So this is real data,
right.
And that I just did, surface that data directly into the platform. None of this is in our traditional storage, but this is all pulled out of our big data.
So this is pretty much that's data from HBase appearing in what looks like a regular Salesforce record detail page.
Yeah, exactly. But the key thing here is that we can run these queries, and this data is immediately for it. So what we're going to do is this organization is trying to profile these customers here. So we'd like to kind of scope it down such that we could understand who are the kind of key writers we want to go after. So the first thing they want to do is they want to say maybe they're going to try a Sokol approach and say, okay, well, could I possibly Sokol this? And I want to do the same query, but I want to only get the writers that have a star rating of 5. And what's going to happen here? That's going to not work because as I said earlier on, IDs don't work. Okay.
Well, ID is the only thing.
Yeah, well, so that's right. ID is the only thing that works. So star ratings, that can't filter on that today. So what am I going to do? So I have the option of doing an asynchronous query. So this is what I have here. So I'm going to take the same Sokol that I ran here. I'm going to push it into an asynchronous query, and then I'm going to directly answer this into a reduced data set. So what this query actually does here, and I ran it a few minutes ago here, you can see an ID here as an example of that. It will take the 1.6 billion records here and reduce it into a smaller data set, and that's going to go into the writer reduced object here. And you can see again we have that definition here. We can just kind of validate here that I've actually had somewhere for that to go. Okay, so then that's a reduced data set.
Right.
So I'm not going to kick it off today right now because
It'll take a few minutes.
It could take a few minutes, and we want to be conscious of our time. But what could I do with that? Could we do with it? And you made the really interesting point. We're like, okay, you've done some interesting data preparation. Now let's kind of maybe take a look at this in Wave. All right.
Here we go. So this is the reduced data set.
Yep.
So we kind of like filtered out the users that we're interested in.
Yeah. So we only got the 5 ratings, so I've started rating here. Yeah. So and what we're going to do here is we're going to start, analyzing their journeys here. So, I did a bit of preparation before, just for in the interest of time here, but I can say start lat and start long, start grouping together where you see clusterings of journeys occur. And then just as a last kind of thing, what we'll do here is we'll just say filter down to say, we're just going to say take this particular grouping here, just to show everyone this is indeed a live data set. And it's going to filter down here, the spinning wheel is going to spin here, but it's actually going to do one last piece of filtering for this data set so it can understand, okay, here are the folks that we're going to go after. So what am I going to do with this reduced data set is I'm now going to say, all right, let's make a chatter post for my marketing folks who are now going to market directly to those guys going, these are our reduced sets for our target commute campaign. All right? All right. And we can post that, and off we go. So that's a great example of being able to process that data and pushing that out. And when you bring up your writing app, you're now going to say, oh, hey, I've got this. I've been profiled here. We now have this new service. We're going to group you together with some key services that we did not have before. So it's a great example of taking billions of records and doing something interesting with it. But not only that, it's joining together with your core CRM data to actually do something insightful.
Yeah, I mean, it dovetails right into Wave there.
Right, totally. Okay, that's the first demo. Let's do another. Up for another?
Yeah, absolutely.
All right, so the other kind of interesting thing to look at is the kind of archival use case. Mm-hmm. And this is whereby we may wish to say, archive some cases. And you think you touched on this earlier on. I have another kind of pretty cool big object whereby we want to take a set of cases and move them into the archive big object. So I define just case and case number and subject.
But you could have any number of case fields here.
Absolutely, and just for simplicity, just for readability, we just took this. And what we're going to do here is we're again going to do a async query to actually run that again. So what the async query is going to do in this case, it's actually going to archive these records directly for us. So we'll go back to here. And this query is a little different because it's going, get me all the case numbers and the subjects where the case is closed and shove those records into the archive big object here. And if I kick this off, and on most note I'm doing a post here as well, it should hopefully work now. It wouldn't be a real demo if I didn't do that. So what we're going to do is
refresh.
Try that again. And let's do this again. I think we can do this again, don't you?
Yeah, I think it's going to work this time.
I think so too. And there we go. Off it goes. All right.
Nice.
So what's happening now is we're actually copying those records from the case object directly into this new archive.
So this response means that query has started.
Yes. So I can take this ID here and go, boom, let's go get that specific ID here, and it'll tell me how things are progressing. And of course, I'm having some issues here. Let's try that again, because I didn't do this right. There we go.
I think it was a slash on the end.
Yes, I think maybe I had a typo in there. So there you can know this is running, and we know what is actually running here.
Right.
So this is cool. So I know this is running, and it's going to run for a couple of minutes here. But again, I ran this a little early on, so we can actually look at this archive big object. Let's run a query on it to understand what's going on here. So I have it right down the bottom here. So I actually can run, a query against it here. Just say, let's pull out the fast, 10 records of what that might look like. And there we go. So these records are available here. But you also ultimately can, you can map them into, we'll get to that piece of an example as well. So you can see, these records are immediately available to you in a typical big object. All right, so one last piece we need to talk about. So we said about, well, what would we do if I, 100, so 50 billion records in this case, BigObject. But some of those cases, I need to bring them back.
Right.
Why would I need to bring them back? Because
run a report
or build a dashboard.
Right.
How would I do that? So here's how you would do it. Literally, you flip around the async query that I just showed to you here. You run it as such, whereby you take this query here. Oops, hang on.
You're in the.
Yeah, we'll go to the right one here. Let's go up. Okay. And I'd run this query here. Notice it's slightly different here. Instead of querying from the case object, I'm querying from the big object here. And I'm pumping those records back into the case object.
So all you've done is flip those two object
change it around.
names. Yep.
But that's how you can rehydrate those records back from your kind of big object store. And then you run a quick report, and they're all back. Okay.
Nice.
I did that just a few minutes before our presentation. So this query is actually actually live. As you can see, I've done this several times because I actually have 114,000 records. We're only showing the first 2,000 of them.
Right.
So we can kind of go back here, and which one is it here? We could pull that ID back and see how things are progressing. So let's get back to the presentation, and we can kind of keep going, moving forward. Good so far?
Absolutely, yeah. Right. How do we get our hands on this?
All right, yeah, so let's talk about that. So we have, active pilots across the board. I'm very much looking for new customer use cases. We're getting a ton of interest already on this, and my team are really excited by the kind of feedback we have been seeing so far. And I think, what we have right now, we can do list views and detailed view of an object, but we're working on related lists, and SFX is on the way too for the new Lightning experience. We have these currently available data types for a number of texts, date, time, and lookup. We're working on related lists. Large text fields is one we hear an awful lot of. JSON type as well, and the system type as well. And then in the API world, we right now, the user experience is very much create only today. We don't have deletes. We're going to add full create, read, update, delete for metadata, and create, read, delete for data. Now, that's an important definition here. You talked about how developers need to be conscious of these things, have very specific behaviors. There'll never be update on a big object. If everything you put in it, and a big object is always additive unless you're deleting it.
So, and an update for metadata might be what? Adding a field.
Adding a field.
Right.
It's not necessarily changing the metadata types, the type of a field, but yeah, very specific metadata updates that you could have.
Right.
And then the setup user experience right now is view only now. The full user experience, so you can do all this using our UI, will come in 2016. So yeah, you've got to be comfortable with our APIs to work.
And if I get on the pilot in my D org, just how many records can I have?
It's really up to you. So how many records you have is, practically speaking, we've seen customers like saying, I want to put 50 million records in my big object just to test this out.
Mm-hmm.
That's pretty common.
Right.
I think we'd have no problem with that.
So it's really down to your ingenuity in being able to generate that amount of data and wait for it to happen.
That's right. And I think, I'd be conscious that, with the DE org, there are some kind of typical limitations that we have. But I think, in this initial perspective, I typically talk with an awful lot of people to make sure that they're going to get success out of it. But in anything like this, you start relatively small and you iterate, Okay, so with Async Sokol, in our current capabilities, as I talked about today, we've having and daytime filters, but we're going to extend some of the filter capabilities very much with the conscious notion that a lot of the records in BigObjects are events. So you want to be able to have very a concrete time bounds on these filters. So we work to do in making sure that we've full bore daytime filters and daytime capabilities and literals that we need to do there. Support for booleans, nulls, multi-site pick lists, all these kind of filters that people are looking for right now. The relationships that I showed you can only go one deep right now. We want to be able to go more deeper and also be able to do subselects. And some of the clauses that are not there right now, limits, offset, group by, and type of are all coming. And the setup right now, it is all API generated right now, but we'll have an Apex experience moving forward.
So workbench is the UI.
Yes, the workbench is the tool of choice right now.
Awesome.
So we are almost there, but let me kind of finish off before we can do some Q&A. what's your call to action? So, we got data archive, BigObjects, async, Sokol. These are our key kind of questions that we have. I'm actively looking for future participation, and participation is free. Let's not forget that.
That's a bargain.
It is a bargain. But you can make your voice heard. I have a very active BigObject chatter group that I let everybody.
Is that on the success community?
It's actually on 62 right now, but I just wire people in. It works as in communities right now.
Okay.
And I think that's as a function that you need to be part of the pilot. It's not necessarily not public. Or you can find me on Twitter, and you can build out your use cases. So we have a huge variety of folks working on this stuff. And I think as Pat and I were preparing for this, the prospect of billions of records on platform, that alone is very exciting. It's going to free up and open up a ton of opportunity and discussions.
Absolutely.
So great. With that, before my voice gives out, let's pivot to questions.
So one question, it's a good question, and we kind of covered this a little bit. How is it different from Analytics Cloud?
Okay, so what Analytics Cloud gives is an amazing visualization and a user-driven way of parsing and filtering and understanding your data, but in a very user-driven way. This is very much more of a programmatic tool whereby you can do batch and prescriptive analytics across your records. We also do it at much greater scale because we have kind of core Hadoop components directly at our disposal, so we're able to parallelize in much greater fashion. But my sense is that this is hugely complementary to our analytics capability within Wave, just as we showed earlier on.
Right. This is the way that you create the data set that you then operate on with.
That's
with
exactly right. I mean, and you're not going to lump unwieldy data sets that have not been prepared into analytics and expect to be able to glean insights from it.
And another great question: does keeping the records in BigObjects versus keeping them in SObjects provide any benefit from the platform disk cost point of view?
Yeah, so ultimately it will. I don't want to get into specifics on pricing models in this call, but that is the obvious opportunity here. It offers some relief on your core transactional OLTP storage that you have on platforms. So we are looking at a couple of models. Part of the advantage of being in the pilot process is that you'll be able to make your voice heard as to what's going to work for you. There will be some cost to it, but that's TBD right now.
But you could, it would be reasonable to assume that if I've got like 100,000 objects in traditional SObject, 100,000 records in traditional SObject, and versus in a BigObject, the BigObject will probably be cheaper.
Yeah, that's a fair assumption, but keep in mind also you're getting a very different kind of set of services.
Yeah.
Right. So it's like they're serviced very differently. Mm-hmm. So it's very much, well, what kind of use do you want of those?
Yeah, it's not just I'll put it here because it's cheaper. You've got to really think about, okay, it makes sense for this to live here because it's static data and like the access patterns. So, I don't want to report on it.
Yeah, exactly.
Okay, so which edition will have this feature? Is that kind of under consideration?
Still under consideration, but for now in the pilot, I have it wide open so everyone can take a look.
Can we handle attachments to records?
Not yet. It's coming. Absolutely, that will come.
All right. And are we going to offer it globally across our different data centers? So customers have a need for keeping data within the EU, for instance.
It is available across every single instance that we have, AP, NA, and EU. Everyone has it right now.
The pilot. Wow.
Yeah, it's just fully global.
What else have we got? Oh, what is the $_B in the target object? Now that signifies that it's a big object, right?
It's not a typo for sure. It basically is our suffix indicator that this is indeed a big object. Right. As opposed to __C, which would mean a custom object, or __X, which would mean an external object.
All right. And the question actually that's not specific to BigObjects, but it's kind of useful to call it out, about how App Cloud is different from Sales Cloud. So the way to think about this is that you have what you can think about as our SaaS applications, so the Sales Cloud, Service Cloud, Marketing Cloud, and so on. And the App Cloud, it's Force.com and Heroku, and it's the way that it's the platform that you build your apps on. So you can build apps that certainly extend or integrate with the sales or service functionality, but the App Cloud is that set of platform features where you get to build your app. So we just kind of cover that off because that came up as a question. It's not the first time I've heard it. Okay. Let's see. As a pilot member already, when will date querying be available in Async Sokol and additional field types? Now you covered that off in the
so in our release that we're going to be pushing out in spring 16. We've made some progress. Some of the date types that we support. I think I know who's asking that question too. That's coming, but there's still. I think that's. I would say this. For the date filterings that we have asked that we've seen, that is probably top of mind for where we will extend our Async Sokol capabilities. So that really facilitates a ton of our event-based driven use cases.
And do BigObject records count against storage limits the same way that SObject records do?
No.
They have their own set of limits.
They will have their own set of limits. Absolutely.
Okay. Let's see. What's the difference between Lightning Connect and Big Data, BigObjects?
They're similar in a point in terms of they look and feel just like any other object. But that's where the similarities end. So with Lightning Connect, you need to have an OData endpoint in order to wire in that external data source into the platform. So the data doesn't exist on our platform. Every time we interact with it, we're running a query over the wire to talk to the SQL Server or the SharePoint or the Oracle backend that you're working with. The difference with Big Data, with our BigObject, is that this data is right next to your core CRM data.
Right, it's on our platform rather than being external.
So it makes for what I showed you, being able to do these cross correlations to be able to machine across this data much more practical. You can do it at scale. I think one of the number one rules of doing data processing is you process the data where it is. And Lightning Connect is much more suited for integration for very discrete, very highly targeted queries. It's not really suited to be able to do large joins between major data sets. In fact, we limit what you can do.
Right. How long is the SObject result set for an async Sokol query accessible to the application? Does it expire or time out?
It's got no TTL on it right now. Okay.
Right.
We may look at changing that in due course. So the target SObject or BigObject, frankly, is for as long as you want it.
Right.
So I think there's a couple of ways to think about this. For an async query, if you were running a bunch of async queries, I would say, put your answer into a BigObject. You're going to have a lot more flexibility there long term. If you want to target an async query into an SObject, either be very targeted as to what field you're going to update, and it should be a more discrete answer that you would have. Because otherwise you're going to end up consuming a lot of your core production storage.
Right.
But again, I think over time, as we move forward here, I expect very much to see a trailhead on BigObjects. There's a bunch of patterns that we want to make sure people understand. So because with anything, we don't it's a tool by which you can use in a good way, but you've got to be careful how you use it.
A couple of really good questions here, really developer-focused questions. So you talked a lot about queries.
Yeah.
What about DML? How do we populate these if we want to, say, capture clicks as a user's navigating around an app?
All right. So if you want to, click, say, I clicked on a link or whatever else, or a banner button. So these are kind of custom events. So that's where, shall we say, Apex, an insert in an Apex perspective may occur. So, So we have a number of customers who are looking for this. Now we don't have the capability of doing insert from an Apex runtime. It's all from a bulk API perspective today. However, we are definitely going to offer an Apex insert capability. There's too many customers out there who want to do just that. Now, there is a workaround whereby if you want to do record those clicks, you could do an insert into an SObject and then pull those records directly into a BigObject to, shall we say, drain that SObject over a kind of in a scheduled fashion. You can do an async query to do that. It's not a particularly pretty approach, but we want to surface an async insert into BigObject, and that likely will hang off the database class. So
right now, some assembly required, but that's
it is possible. We do have some customers doing that. We have actually with one ISV Taz Group. They presented me with me at Dreamforce last, and they had a demo there. You guys can check out the video on that.
Okay. So can you write trigger workflow and those kind of rules against BigObjects?
So you can output to a BigObject, but because the data doesn't mutate in place, triggers don't work. Okay.
Right.
However, I'd be interested to learn more about that specific use case as to whether we should do more or on that one. The notion of an update to a BigObject because it's getting another record is potentially a trigger-like experience. Okay?
Right.
So I'm open to that discussion.
So I guess the key is get involved in the pilot and try it out and give feedback.
Yeah, I'd love to hear the use case on that. I would love to have something along those lines.
Okay. Is this available in Winter 16 release? Well, yeah, the pilot is currently available.
Yeah, so in terms of what's available, there's implementation guides, how-to guides, all are available today, and a very active community on this.
So let's say you hit the close window button on that workbench. How do I check the job ID?
Yeah, so what you would do is you get, what you would do is you would, let's bring the demo back up here. Let's see if we can have a job ID that we have running right here. You get this ID here, and you can pull that ID off and append it to here.
Right.
And that will, too much. Okay, and you can execute that ID and it would give you an output just like you see before, which would tell you the state of your running async query.
But if I forgot that job ID, is there a way to see what are all the jobs that are currently in process?
In Winter 16 there is not. In Spring 16 there will be.
Awesome. Great.
Yeah, so just like, what are my current running async queries? Give me a list of all those IDs. Those that are completed, those that have not completed, all that kind of stuff. Yes, it's coming. Great question. To that question, I have forgotten them on many occasions, and that's one of the reasons why we did it. So. Right.
And I guess we should have like an under construction banner on this.
Yeah. So the guy was digging or something.
Yeah. Really interesting one. Will BigObjects be packageable for ISVs to build apps for the App Exchange?
Once we GA this, yes, it will. Absolutely.
Right. And will BigObjects be available in developer orgs once the pilot is done? Well, they're available in developer orgs
today.
Yes. Right. So you can literally go create a developer org at developer.salesforce.com/signup, and then tweet at Jonathan on Twitter, and he'll sort you out.
Yep.
Okay. So it's a good question. I guess there's a lot of variables, but finger in the air ballpark, how long would it take to put 50 million records into archival using BigObjects?
So for those who are watching my slides skip quickly by, I sketched out a goal as to how quickly I want records to get in. The goal for BigObjects is to be able to put 1 billion records in within 24 hours. We're not quite there yet.
Right.
In our subsequent release in Spring 16, we'll be able to do something in the order of 400 to 450 million records in one day.
Mm-hmm.
So 50 million records would take,
2.5, 3 hours.
Maybe that, something of that nature.
So that's not bad.
But yeah, we're going to be iterating rapidly on that at this point.
Right. Documentation.
Yes, we have an implementation guide that we will share post this. I think it was on our original advertisement for this
I think it's on the webinar page.
It's on the webinar page, yeah.
And if it's not, we'll ensure that it is. Go ahead. Which one? How is it different with Heroku and Heroku Connect?
Yeah, so this is very much focused on the Force.com component of the App Cloud.
Mm-hmm.
Heroku and Heroku Connect, or Connect obviously being the bridge so that you can move records efficiently between Force and Heroku. And Heroku Postgres is the underlying database that they typically support. It's a different experience. Okay, I think if you take the Heroku Postgres, Heroku Connect, you very much want to bring your traditional database skills to bear to should be successful with it. This is built with very much the Force.com developer in mind, such that you can think in terms of a typical Force.com developer. We're trying to stay true to that.
I suppose if you had, it doesn't make a lot of sense to say, okay, I've got an app on Heroku and I've got 1 billion records in Force.com. I want to sync them across. Yeah.
Well, I think here's the thing with asynchronous query, because very often the case you may have a customer-facing app on Heroku, right?
Right.
But you have a bunch of CRM data on Force.
Right. But you could extract.
You could do the federation. You could do the data processing with actually moving the records with async query. So if I want to give me a sort of 20 records out of a billion records, I could direct async query to do that for me, to go process these records for me, give me an answer and present those in a BigObject, and then I could discretely move that out. So it engenders a much more efficient way of working with our data across our platforms.
Okay. Can we edit BigObject records? I think I know the answer to that one. No,
that's
because
correct.
They're immutable, they're write-only.
That's right.
And that's part of the trade-off you get for the ability to have these billions of records. How do you keep track of changes to objects? I guess how do you keep track? How do you know when more rows have been added to your?
So every time you insert a record, you get a new ID. Okay, so it's always additive.
Okay, so I guess you could. There's no triggers right now.
Nope.
So I guess you could periodically select count.
You could do a count, but you can only do an aggregate with async query. So you can do an update count. So one way I do it is I run an async query on a nightly batch, right? And then I run a count against that, and I put the answer of that count into a SObject, but I track the object, and basically then I have a record of how that object has grown over a period of time.
So can I? I'm just wondering if you know that, say, yesterday's count was 1 million and today's count is 1,001,000.
Right.
Is there a way to get that last 1,000 records?
Yeah, so it's a great question. So we don't have the system types in there right now, but once we have the system types in there, that will become much, much easier.
So you can just order by created date, limit 1,000.
Exactly. That's where it's comes.
Yep. Okay. I'm a student majoring in big data and analytics. How can I get associated with the BigObjects pilot? So
I think it's developer work there, yep.
Yep, just go create a developer edition, so developer.salesforce.com/sign up and tweet at JONBRUCE. Okay, will the BigObjects store be subject to all the awesome security and what's that, data resiliency?
Yeah, data recovery.
Disaster recovery.
Disaster recovery, yeah. Yes.
Of the Force platform.
So I'll put it to you in a very concrete fashion. So, if you look at trust.salesforce.com, Parker has this great quote, most important value. So that's what we have been working on for the past couple of years to make sure our HBase infrastructure is at par, such that, we have, all those available kind of trust capabilities. So yes, I would not even be having this conversation.
Okay, so we're at the top of the hour again. One final question, because it's something that you actually demoed, but you just demoed it. The kind of running the analysis. How did you actually get the data from BigObject into Wave Analytics?
Wave sees any material Salesforce object just like an SObject or a BigObject. Just looks like the same thing. You just pointed at that and ingested it.
So it's just a source that you can choose when you're setting up your analysis.
Exactly.
Awesome. Well, I want to thank you, Jonathan. This has been a great webinar. I knew a bit about BigObject, and I've learned an awful lot, and I hope our audience has as well. So where you can go from here, definitely, I mentioned it a couple of times, either in, I guess, the sandbox. You can have this in the sandbox.
Sure, sandbox, production. By sandbox, frankly, developer edition is a great one. If you've got some thoughts, in success community, you want to do more there. I have my own chatter groups as well within communities. But yeah, love to hear a lot of your sources, and there's a bunch of materials that we have where I've done these demos and more, some of our partner demos as well in past Dreamforces, so you can get a real sense of what the capabilities are here. But let me say thank you to Pat for having me, and thank you for the amazing amount of questions we got. It was really fantastic.
All right. Well, thanks a lot, and have a lot of fun and be productive with BigObject.